All right? Realized I forgot to record the notes from yesterday, so I'm going to go back and kind of explain some things more, so I'll post that. So, with this, remember, we've got to write down our given information. We've got 62 kilometers. Our next step is to do what? Right. Put the unit you're trying to get to all the way at the end. That's just going to help guide you along. All right. Now, one thing I don't know if I explained as well in this class as I think I did my other class. Guys, the whole idea of conversions is that we're multiplying by fractions that are equal. Okay? So we're multiplying by 1 every single time. The only thing that changes is our unit. We're trying to go from one unit to another. So every time we write a new fraction, all right, that fraction, those numbers that are in there, it's multiplying by 1 because those numbers are equal. So like we said yesterday, 1 foot equals how many inches? 12 inches. That's the same. That means, guys, that those units, when you put those numbers with it, they're the same thing. 1 foot equals 12 inches. They're synonymous. They're unanimous. Or not. I'm using the wrong word. All right, but they're the same thing. So that when we multiply, whether we write a fraction like 1 foot over 12 inches, or we write 12 inches over 1 foot, those two things mean the same thing. And we're just going to multiply our original number by different fractions until we get to the unit that we want to end up with. All right, so that's, again, a brief overview of what we're doing here with this conversion process. So, we have kilometers. We're trying to get to meters. Can you go right from kilometers to meters? Are they related to each other somehow? Yeah, we looked at our notes yesterday, guys. If you look in your metric chart that you had, right, we saw how meters and kilometers were related. So what we're going to do is we're going to make it fractions. We're going to multiply fractions by other fractions. So how can I make this a fraction without changing the number? Just say it. Just shout it out. Yeah, just put a 1, right? Now the purpose of that again is a placeholder. What I have found in the past, all right, when I first started teaching this stuff, I never put a 1 there because I just assumed that, my students, hey, they knew it. I don't take things for granted anymore. Put a 1 there, guys, as a placeholder. What I've seen is that people will start to put units in the bottom of that, and then it messes all of their calculations up. So if you put it there, you know that, hey, that space is taken care of. All right, I'm not going to add anything to it. Then I'm going to just multiply by another fraction. Well, if I write a fraction here, how do I figure out what goes where? What am I going to do? I'm going to let my units drive your math. So what I mean by that, every year, again, I think that people know what I'm saying, but then I find out later on in the year, what does that mean? Before you set any numbers up in this fraction, get your units right. What do I mean by that? Well, do I want to stay with kilometers? No, I'm trying to get to what? Meters. So kilometers, I need to get rid of this. Well, in order to get rid of it, in a new fraction, where does it have to go? On the bottom. Why? So it'll cancel out, right? If you divide by something, you erase it. So those will be canceled out. So that means meters is going to go on the top. Well, now we're looking just at this new fraction, this factor. Okay? How are meters and kilometers related? Well, when you have something, guys, when you're dealing with a metric system only, whichever unit has a prefix, we're going to put the number 1. Okay? And you'll see why that is as we go along. So that's like we're saying that 1 kilometer equals a certain number of meters. How many meters are in a kilometer? 1,000. Now, how would we write that in terms of a exponent factor? Good. And again, there's just a pattern with it, which is why we're going to write it as 10 to the third. Now, you guys, in your reference packet, you have that prefix defined for you. So you don't have to memorize it. It's there for you. Other ones, like hecto and deca, those are not given to you, but the other big ones are. Is this the unit I'm trying to get to? Right here? Yep. So there, I'm done. Now all I have to do, guys, is multiply out my fractions. The ones aren't going to matter because they're dividing by 1. It's not going to change anything. So it's 62 times 10 to the third, which is going to be 62,000 meters. Right? Now, again, I know we did that one in class yesterday. I just wanted to kind of review it. Now we'll move a little bit quicker. The other way that you can write this, guys, is you can write out fractions if you want, but you're going to see me write out a T-chart. I believe, is that what I did for you guys in class? Right. So I'm going to write out a T-chart. It means the same thing. Anytime, guys, you get to where that line is, all right, it means you're multiplying. Okay, it's a new fraction. That's all that means. It's just a kind of a streamlined approach with it instead of writing out fractions every time. Again, try to buy into this system now because it's going to make your life a whole lot easier down the road. I realize that dealing with the metric system, you guys can probably do a lot of these problems in your head by just moving a decimal, right? We're not going to be dealing with the metric system, those types of calculations all year. We're going to be doing other things where we're going to apply this method. And I promise you, if you can do this and not just kind of get through it, if you can understand this process, your life in this class and beyond, not just in chemistry, guys, but if you go into anything, engineering, math, science, medicine, anything related to that, or even other classes, you'll probably find uses for it. It's going to be a great tool that you can use beyond this class. All right? So here we go. Let's take a look at the second one. First step is to write my given, your known information. So 3.2 liters, I'm trying to get to decaliters. Okay? So maybe you want to think back to your chart from yesterday, right, where we had kilo, deca, nope, I already messed it up, hecto, deca, your base unit, you have deci, centi, milli, and so on. All right, it was 10 to the third, 10 to the second, first, 0, -1, -2, -3. Okay, just as a reference. Or, if you want to get your reference packets out and look at Table C, I highly recommend it. If you don't have a calculator, get up and grab one because you're going to need one here in class today. Once you have your given and your wanted down, set up a T-chart. Okay? I will typically, guys, just set my T-charts up with one other fraction. Do you think we're always going to have just a one-step process to solve? No, we're going to have multiple ones later on, but it's okay. Start with one. As you need them, you can write in more lines and more fractions. All right, what am I going to put below that first one? A 1. Why? It's a placeholder. That means I've put something in this blank. I'm not going to write anything down there. I'm not going to put a unit down there. I'm not going to put another number down there. It's just a 1. Okay? Now, think about it. I'm trying to go from liters to decaliters. Do I want to stay with liters? No. Where does that unit have to go to cancel out? On the bottom. So, guys, here's a little hint. Even if you get confused with this, and on a test or a quiz, you kind of forget the process. If you jot this stuff down, okay, my given, my final, and you set up a T-chart, every single time, no matter what the problem is where you're doing a conversion, the unit you're starting with will go down here in this one. If you show me this, I'm going to give you partial credit. Okay, I'm going to give you at least a point for making an attempt at a problem. All right? Put that down. I don't want to. All right, so liters is on the bottom. What's my unit going to be on the top of my new fraction? Decaliters. And if I think, or if I go back, think to yourself, can I go directly from my, liters in this case, right? Base unit means meters, liters, seconds, and grams. Can I go right from here to there? Absolutely. It's one step. You'll see what I mean by a two-step in a few minutes. All right? So now I can go ahead and cross out. Liters are gone. How are liters and decaliters related? Well, which one am I always going to put the number 1 in front of it? Not the bottom. Not the top. Now, it's obviously bottom or top, right? But remember this fact, guys. This is going to help you when we're dealing with the metric system only. Whichever unit has the prefix, what do I mean by prefix? Deca, hecto, kilo, all those ones, guys, those metric prefixes. That's where you're going to want to put the number 1. Okay? Because, and I'll come back to this so you can write it down. Guys, all of these numbers here are in relation to your base unit. When we say kilo is 10 to the third, it's 10 to the third what? 10 to the third grams, or 10 to the third meters. If we say a decimeter, it's 10 to the minus 1 meters. Okay? So these numbers that we wrote in here, these factors, they are all in relation to that base unit, whether it's mass, whether it's liters, whether it's seconds, whether it's grams, okay? So the numbers that we have there, why I have you write it like a factor is you don't have to worry about moving decimals around or anything like that. That means that this process, if you put a 1 in front of the metric prefix when you're doing a conversion in a fraction, the other number is going to be the 10 to whatever power. It makes it simple, makes it streamline, that whole process, when we're dealing with a metric system. Okay? Okay? And that, I'll be honest, this process, my students that I've had in the past, they struggle more with this process with the metric system than they do when we go from other numbers. So, again, do your best with it. If you have questions, come see me. All right? Ask those questions, because that's what I'm here for. I promise this will only get easier down the road. But here we go. That's all we have to do. So now, just multiply your fractions together. 3.2 times 1, 3.2 deciliters over 10. All right, do I have a unit on the bottom anymore? Nope. Okay, that's all I have to do. Now, do you have to, am I going to make you guys rewrite this new fraction? No. You can go ahead and do the math, all right, on your calculator. That's fine. I'm just showing you what we're doing. When I do this math, what do I get for my final answer? Absolutely. There's my final answer. So the last thing you want to ask yourself, does my answer make sense? So if I go back here, I want to end up with deciliters. I started here with my base unit of just liters. Does that make sense? If I have liters, should I end up with a smaller number in the end when I go up to the higher part? Absolutely, because these numbers, guys, these are bigger units, so the number is going to be smaller than what you started with. If we went down on our chart, okay, then we should end up with a what number? A bigger number, absolutely. And that should be a review for you. Just think about it. Does my answer make sense? I want you guys to do the you try problem that's right there. If you already worked ahead, just sit tight. What's my first step always? And again, I just keep asking that. It's going to be any problem we have, no matter what it is. Always write down the information that you're given first. It'll help guide you. So we have 320 centimeters. We're trying to get to meters. Okay? I'm going to set up a T-chart. Again, it's the same process each time. What goes below that first number? 1 is a placeholder. You'll see, maybe tomorrow, we're doing practice. You guys will see the only time where something would go down there, but we're not going to get into that right now. All right, I'm going to get rid of centimeters. Where does it have to go to cancel out? It's got to go on the bottom. That means meters will go on the top. So centimeters are gone. Now I can figure out my numbers. I'm letting my units drive my math because I set my units up first. The math, meaning the numbers, will follow the units. Which one, when I'm in the metric system, which one gets the number 1? Which unit? Why centimeters? It's the one with the prefix. So it could be on the top sometimes, it could be on the bottom. Instead of trying to remember, which one goes on the top, which one goes on the bottom, just look for that prefix when we're dealing with the metric system. 1 centimeter is how many meters? 10 to the what? So this is where we're having that. Again, you have it in your reference pack, guys. You don't even have to memorize it. Look at table C. It'll tell you what that factor is. It's 10 to the minus 2. So now we can just do our math. All right, 320 times 10 to the minus 2. How many meters do we get? 3.2. All right, you can put the 0 there. You don't have to. Okay. Boom. Bless you. Questions? Bless you. All right. Now, let's take a look at this example right here. Okay, now if you guys, some of you may be very familiar with the metric system, and you guys can do this in one step, that's great. Just be careful with it. I'm going to show it as 2 steps. And this is kind of start to get you thinking about multi-step problems with your units in that T-chart. Bless you. Okay, same process. Write down your given. I've got 17,000 milligrams, and I'm trying to get to kilograms in the end. Let's set up my T-chart. Put that 1 as a placeholder. Now, if we think about our metric sidewalk, okay, in this problem, I'm starting right here. But I need to get all the way over here. Okay? The numbers that we listed out, this is 10 to the 3rd, 10 to the 2nd, 10 to the 1st, 10 to the 0, 10 to the negative 1, negative 2, negative 3. Okay? Guys, those numbers, those are in relation to your base unit. So when you have a double prefix problem, again, you may see it as a 1-step, and that's great. I'll check it for you, but I'm not going to show that. I'm going to show it whenever I have prefix to prefix. I'm always going to make it a 2-step problem. Because what I've found is if I just try to make it a 1-step, I'll confuse some people. But when I do it this way, everybody usually can understand this. The ones who want to do it as a one-step, hey, go for it. Okay? So what I'm going to do here is I'm going to always convert back to my base unit first, then I will convert to my second one. So each arrow shows 2 steps. 1 step and 1 step is 2. So here's what I'm going to do. Okay? Same process. Where's milligrams going to go to cancel out? On the bottom. On the top, though, I'm going to go to my base unit. It's going to be grams. Is that the unit I'm trying to get to in the very end? No. So that means I'm going to need another conversion factor, another fraction. Same process. Now, since I have gotten this far, I'm done with this one. We'll come back and do the numbers in just a second with this, because again, I'm going to let my units drive my math. I mean, all my units set up in the problem first, then I'll go back and do my numbers. So this one's done. This one we'll finish in a second. So now I'm looking just here. Okay? Well, look back to your previous one. Grams is my unit. I want to get rid of grams. Where does it have to go? On the bottom. Same thing. Then on the top, my new unit's going to be kilograms. Okay? Everybody with me? Same idea. It doesn't matter how many fractions. We could keep adding on and on and on. The process is still the same. That's the beauty of this method, is that we can make it as long as we need to for as many steps as we want. We can keep doing that same thing because, in the end, milligrams is on the top, it's on the bottom, it's going to cancel out. Grams are on the top and on the bottom, they'll cancel out. What's the one unit we're left with? Oh, kilograms, which is what I want over here in the end. Okay? Now that's the unit portion of it. Let's talk about the math, the numbers. So take it one fraction at a time here. Okay? So I'm going to isolate this fraction in the middle. I'm dealing with just grams and milligrams. Okay? Don't worry about the beginning one. Don't worry about the end fraction. Just this middle one right now. Which one gets the number 1? Milligrams. Why? Because it has the prefix. So 1 milligram has how many grams? If I look down here, milli is 10 to the minus 3. All right, that fraction's done. Now I can move on to my next one. So now I'm looking at this fraction, grams and kilograms. So you see, you're changing your reference of what you're comparing with each fraction. Don't try to compare, this kilograms to this milligrams, or this to this, or this to this, or you get the idea. Take it one fraction at a time once you set those up. Okay? So, which one gets the number 1? Kilograms, because it's got a prefix. How many grams are in a kilogram? That's this right here. 10 to the third. There we go. Now we just have to do the math. Okay? So go ahead, guys. When you're doing it in your calculator, now these are pretty easy because there's some ones and stuff. It's pretty straightforward. We're not always going to have ones on the top and the bottom to make it easier. So here's what you want to do when you plug it in your calculator. This method is a little bit longer, but it will get you there the correct answer every time. I'm going to take the top number here times the top number times the top. And this is how you would plug it into your calculator. Okay? Top times top times top. Then I would hit divide by bottom, divide by bottom, divide by bottom, equals, it'll get me the right answer. You can use parentheses, you can do all that other stuff if you want to, but the more keystrokes you use with your calculator, the greater the chance there is to make a mistake. So when you have a multi-step problem, I like to go top times top times top, divide by bottom, divide by bottom, divide by bottom. Order of operations is the same thing, whether you do it either way. You could rewrite the fraction and rewrite your new top. Here we would have, 17 kilograms divided by 10 to the third. Doesn't matter. Same thing. Okay? Just make sure you get that answer and you take your time with it, however you plug it in. My final answer here is going to be what? Absolutely. There you go. Questions? All right. Write my given placeholder. So I'm going to go ahead and go from millimeters to my base. Then I will go from my base to my second one to make it a two-step problem. Millimeters on the bottom, meters will be on the top. So I'm going to go ahead and get that fraction taken care of, then I'll move on to the last one. I'm going to put a 1 down here with my millimeters because it's got a prefix. That means the top number that's with my base unit is going to be 10 to the minus 3. Okay. Then I'm going to move on because I don't want to stay in meters. I want to get to decameters. So meters is going to go to the bottom. That same process of canceling out your units, decameters on the top, meters will cancel out. So again, new fraction, all right, the one with the prefix gets the number 1, and then my other one's going to get, my base unit will get the bigger number, the exponent. 10 to the first, then all I have to do is do the math. Who can tell me what they got for an answer here?
I got 20.54.
Do you guys agree with Tony?
Yeah.
Should be 0.054 is what you should get. If you got something different, double check your math. Double check your math.